What is up, mathletes? Welcome back to another episode of Math with Dr. Math. And in this video, we're going to look at the big ideas in probability. We're going to go over complements, at least and at most statements, and then at the end, you're going to get some practice. So don't go anywhere. All right, so let's go ahead and let's start with this idea about the complement. The way I like thinking about the complement in probability is like the opposite. And two things to remember, all right? Number one, whenever you have probabilities, they always add up to one, right? Because when we think of probabilities or percentages, right, they always have to add up to 100%. So we want to make sure we're going to start off with notation. So we have the probability of A bar, or the probability of A, and it looks like it's raised to the C power. But both of these are just the notations that we're going to use when we're talking about the complement. So if you see any of those two notations, they're just asking you to find the complement. All right, that's all they're asking you to do. And so to find the complement, what you do is you take 1 minus the probability of that event, we'll call it A happening. So the complement of A is 1 minus the probability that A actually takes place. So let's get a quick little example just so we wrap our heads around it, and then we could move on. So let's say the probability of A taking place is 0.30. So to find the complement, which is A bar, right? To find the probability of A bar happening, then you just take 1 minus that 0.30, and that's how we get the 0.70. So it's that easy, but this little idea, you're gonna see it used throughout statistics, and it's gonna be a powerful and very helpful idea. So let's see how we could use it. All right, so the Dr. Math team, they went online, did some research for you, and so check this out. According to creditcards.com, around 40% of Americans' households have revolving credit card debt. That just means every month they have that credit card debt that's still there, right? They don't pay it off, all right, from month to month. What is the probability that a randomly selected household, right, randomly chosen household, does not have a revolving credit card debt? All right, so using the idea of probability, what we do know is the probability that they do have, we'll say credit card debt, so we'll call it D for debt. So the probability that a household does have credit card debt, we just noted that it's 0.40, right? So the question is saying, what is the probability that a household does not have, right? So what they're wanting is they're wanting that complement, right? So if we know one is 0.40 or 40%, then the complement is simply 1 minus 0.40. So make sure you read the question and what is it that you're looking for. In this case, we want the complement, which is 0.60. So that means that 60%, right, of American households do not have this revolving credit card debt. Make sense? Follow me to our next example. All right, so let's look at this next example. So we have 4 patients. So these 4 patients have made appointments to have their high blood pressure checked at this clinic. All right, so you always want to pay attention to this next part, what you're defining your variable to be. So here it says, let X be the number of them who have high blood pressure. So this right here, this is the probability that no one has high blood pressure out of those 4. This is the probability that exactly one of them has high blood pressure. This is the probability that exactly 2 of them had blood pressures, and so forth. And what you always want to do is just do a quick check to make sure all these always add up to 1, right? To make sure this is actually a probability distribution. All right, so let's jump into the question. Find the probability that at least one of them has high blood pressure. So at least one, right? So when you say at least one or at least whatever, that's the smallest number it could be. And then we're looking at everything above that. So here, this really means the probability of 1 plus or we're also looking at the probability of 2 of them having high blood pressure, or the probability of 3, or the probability of all 4 of them, right? So let me make that 3 a little cleaner. Oh, sorry here. Let's clean that up. All right. So now all we're gonna do is add up those 4 probabilities. So let's go ahead and add those up. So we add up the 0.2, nope, that's the one with 0. So for 1, it was 0.41, right? This is the probability associated to exactly 1. The probability associated to exactly 2 is 0.27. The probability of 3 is 0.08, and the probability of 4 is 0.01. So when we add all those up, we get 0.77, right? And let me ask you this. What if this, instead of having 4 patients making appointments, what if you had 27, right? Are you really gonna wanna add a probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 and then all the way up to 27? Absolutely not. So does it work? Yeah, it works. But we want to see, is there any more efficient ways of doing so? And this is where complements come in here, in handy, right? So another way of saying find the probability of at least 1, we could use the complement, right? And so what we're gonna look at is, notice, let me circle these. Right now we looked at this one, this one, this one, and this one. Well, notice which one was left out? Well, the probability of 0, right? So this was the opposite. This is the opposite of what we wanted. We weren't interested in this. But using the idea of complements, what we could find is we could also find the probability 1 minus the probability of exactly none of them having high blood pressure. And that's going to be the same exact thing as finding the probability of at least 1. So in doing so, we get 1 minus 0.23. And what do you know? Boom, you get the same exact answer. So instead of adding up all these probabilities, what we could have done is just found out, hey, which one are we not interested in? And then by subtracting 1 minus that probability, what you're really saying is you're getting rid of that one. So keep that in mind when they give you an at least problem. So when they say at least 1, just say, oh, that's the same thing as 1 minus the probability of 0. And then the work, you're gonna save yourself a lot of time. All right, folks. So if that's helpful, make sure you smash that like button, subscribe, and follow me to this next example. All right, so now we have an at most statement, right? So again, we have a different scenario here. So we've seen these lines, 15 items or less, right? So the number of customers in the line at a supermarket express checkout counter is a random variable with the following distribution. So these numbers here describe the number of customers in line, right? And this is a probability associated to each one of those, okay, situations. So here it says find the probability of at most 4 customers being in line. So at most, so when it says at most, well, 4 is the most customers we could have, or we could have 3 or 2, 1 or none. So here what we're looking at is we're finding the probability of 0 plus the probability of 1 plus the probability of 2 customers in line, plus the probability of there being 3 customers in line, all the way to the probability of 4 customers, right? And if you notice here, the only one that was left out was that one right there, the probability of exactly 5 customers in line. So can you add up all these? Absolutely. But again, using this idea of complements, wouldn't it be much easier to take that total percentage or probability of 1 and subtracting the 1 that we don't want? And in my eyes, that's much easier. So this is going to be the same thing as 1 minus the probability of there being 5 customers in line. So we get 1 minus 0.05 and we end up with 0.95. And again, that's going to save us a lot of time because yes, this was a short list, but imagine if we had 25 customers, or if our example was a little different where we had a long distribution here. So this is going to save us so much time. So again, I encourage you to review this and make sure this idea of complements makes sense. And just to make sure it does make sense, here's a problem that we want you to comment down below. All right, so go ahead and I want you to try find the probability that x is at least 1. So go ahead, use the method that you prefer and comment down below and let us know what you guys find. All right, mathletes. So hopefully you found this video helpful. Don't forget to like, subscribe, and we'll see you in the next video. Peace.